Hi everyone, my name is Lydia and this is what I wish they taught me about econometrics and introduction. In the previous video, we covered the first condition for a valid instrument, which was relevance. Which meant that the instrument must move X. But relevance alone is not enough. Today, in this video, we're going to cover the second condition, which is the exclusion condition or restriction. And we'll also clear up something that confuses almost every student. Why different textbooks seem to list different numbers of conditions. You will see books that have 2 conditions, you'll see books that have 3 conditions, and most of all, what you'll notice is this second condition is not always named consistently across all of the books. Some will call it the validity condition. So let's dive into it. A valid instrument needs more than the relevance. If we go back to our diagram, we have a Z which affects X, which in turn affects the Y. Okay, so far we've only required this bit right here that Z is affecting the X. But what if Z also affects the Y directly? Okay, or maybe through a channel that has nothing to do with X. Well, that would be a problem, right? Because that would mean that Z affects Y in 2 ways. It would be directly through its own channel or another channel that we didn't really account for, or it can be indirectly through X. And this is a disaster because we can no longer separate the effect of X on Y from the direct effect of Z on Y, which was the whole purpose why we wanted to use an instrumental variable. Think of it this way. If Z affects Y directly, then Y changes after Z changes. So we can't tell whether it was because Z moved X, which then moved Y, or was it because Z moved Y on its own? So the 2 effects then, again, are hopelessly tangled together. The exclusion restriction requires that Z affects Y only through X. No direct path, okay? So the direct path from Z to Y must be excluded from the model. And that's exactly where the name comes from. We exclude the direct path, all right? And mathematically, we can write this as the covariance between your Z, and I'll actually write the error term instead of the Y, because remember, everything else that has not been explained by the Y is in that error term. This is equal to 0. And it seems like it's a little bit squished, so let me move it in here so you can see it clearly. Okay. The education example, going back to it, the distance to university and X being your education. The argument is distance affects education, which affects income, and that is fine. But could distance affect income directly? Possibly. Rural areas have different labor markets and lower wages, regardless of the education that you have. Living far from a university may mean living far from high-paying urban jobs. There's also migration patterns to keep in mind. People near universities may be more likely to move to cities. So if any of these channels exist, distance is affecting income directly, not just through education. So that would mean that the exclusion restriction fails, okay? The exclusion restriction, so as you see, I had to come up with ways in which why and how could distance possibly affect income directly. This is one of the reasons why this exclusion restriction it's sometimes or most of the times a judgment call, which means that if you're ever asked in an exam to explain whether you believe that the exclusion restriction has been fulfilled or not, then you have to come up with some sort of explanation by putting actual context into the example that you have, why that might be true or that why that might not be true. So you have to argue convincingly. And most of the times in those exams, you will not really be judged whether what you're saying is like proven to be correct or not. As long as what you write makes sense, you're going to be fine. So as long as you have one instrumental variable, there's no statistical test that can do this job for you. Okay? So this directly test, this not directly tested as a condition. Okay? Now, let's get back a little bit to that confusion about the terminology, because there's a lot of students who get confused. Different textbooks list different numbers of conditions, actually. In Stock and Watson, for instance, what you will see is that there's two conditions, and they are called the relevance condition and the exogeneity condition. Okay? In other books, for instance, the Angrist and Pischke book, instead you will see there is three conditions. So it's a three-condition approach. The first one is relevance. The second is the exclusion. And there is also the exogeneity. The exogeneity at times in some other books, like the Green, is called also the validity condition. And sometimes instead the exclusion in the three condition framework, it's the exclusion restriction that is called the validity condition. Just keep in mind, they are actually not contradictory. These are just different ways of packaging the same idea. Okay? So, different packaging of same idea. In the two-condition version, exogeneity implicitly contains both the exclusion restriction and independence from omitted factors. So they're bundled together. In the three-condition version, these two ideas are separated explicitly, but both framings lead to the same requirements for a valid instrument. You will also have books in which they call them the relevance and the exogeneity condition, and then they go on to say, and if these two conditions are fulfilled, then you have come up with a valid instrument that affects Y only through X. So as you can see, the wording is always the same. It's just the way that it's packaged that is slightly different. Okay, so in order to make sure that you never get confused, whether it's the two-condition framework or the three-condition framework, let's just look very carefully at each concept. So keep in mind, you've got the relevance condition, which is simply the covariance of your Z and X being different from zero. So instrument moves with X and it's testable. If you have the exclusion restriction, okay, it's no direct path that goes from Z to Y. So Z affects Y only through X, and that is usually not testable. And then you've got the exogeneity. Again, remember, also called validity, independence, however you want it, where we write as the covariance of Z and the U term being equal to zero. Okay, So it's just like saying, once again, that the instrument is uncorrelated with omitted factors. This one is, again, not testable. So the idea is all the same. The instrument must be clean and uncontaminated by the same problems that are affecting X. Okay? When a paper says that, let's say, we assume instrumental variable validity, okay, or we maintain the exclusion restriction, they are literally trying to say exactly the same thing. It's just the naming varies by field and author. Now, why is exclusion difficult? Because we've been roaming around this idea that it can't be directly tested. You have to make a judgment call there and argue very convincingly. We can test relevance through the first stage. The exclusion restriction, usually the answer is no, because, and this comes from the idea that this asymmetry is fundamental to IV. One condition is verifiable with data, the other must be defended with reasoning. There is one partial exception, and that is when you have more instruments than endogenous variables. Okay? Only in this case, you can run a test, which we call a test for over-identification of restrictions. Okay, again, we'll cover this in a later video, but even that test by itself has its own limits. That's why most of the times when you answer this kind of question in your exam, you have to provide a lot of arguing. What do researchers actually do? So without a direct test, they defend the exclusion restriction using either economic theory, institutional knowledge, historical context, or they can do robustness checks. Okay? And keep in mind, it's argumentation, not proof. Usually a good IV paper spends a substantial amount of the paper itself defending why the exclusion restriction is plausible. Okay, a weak IV paper basically just assumes it, and it's the economist's burden basically to be able to prove that and convincing a skeptical reader that, well, the exclusion restriction totally holds. Angerst and Pischke actually famously said that the exclusion restriction cannot be tested, it must be believed. So the quality of an IV strategy lives or dies on how we believe that argument is, basically. So the exclusion restriction, once again, requires Z to affect Y only through X. It goes by many names: validity, exogeneity, independence across the textbooks, but always means the same thing, which is no direct path from Z to Y. In the next video, we'll see how economists actually defend the exclusion restriction in published research and what makes some arguments more convincing than others. So stay tuned, and I'll see you in the next video.